Hello and welcome to the software topic for the Year 11 Computer Science course. What you see here is an overview of all the things which are connected to this particular topic and which are going to help you with your software test. The first thing to look at is to understand what an operating system actually is. Well, it's loaded from the hard drive into RAM at the end of the boot process. Its two main functions are to ensure that any application software is able to work efficiently by supplying the application software both with the processing power and memory space in order to be able to do this job. The second job of an operating system is to make sure that any instructions given by the user to a particular piece of hardware is actually carried out. So if the user wants to print something, then the instructions are given via the operating system to the printer or any hardware, and those instructions are done. There are four different types of operating system. The first one is called a single computer to single user. So in this case, one user would have a single account onto, say, a desktop, or a single user would have sole use of a particular mobile device. The second one is a single computer to multiple users. So here we have a mainframe, a much more powerful computer. And here you might have thousands of users using the same application all at the same time. The third type are multiple computers. Here we have a small scale and a large scale example. The small scale is connected with the home network, where several computers can be attached to create a network. The much larger example is a worldwide one, where to create a large computer network, many computers can be attached over a wide area. Finally, a special purpose operating system would be used either within space vehicles or military vehicles, domestic appliances, or even cars. In the case of a car, you would have embedded computers which would be responsible for monitoring and maintaining an optimum car engine, or it could be as simple as being able to wind down and wind up the windows. The operating system performs hundreds of tasks. We're going to look at just a few. The first one is called the user interface, input-output management. This is all to do with how the user actually connects to the computer. Back in 1985, the way we used to connect to computers and pass instructions to them would have been through MS-DOS, which, as you can see, was pretty boring. It was just specific instructions given through code. Later on was the invention of the graphical user interface, a GUI. This meant that the ordinary user could understand what the instructions they wanted to give the computer. So for example, if a user wants to drag and drop a file into a folder, then the operating system is able to carry it out. Or if a user wants to be able to pass on an instruction to the operating system by clicking on an icon, then the operating system would be able to open up that particular application. And the same would apply with drop-down menus as well. So the graphical user interface is a feature and a function of the operating system. The next one is being hardware independent. Hardware independent is centered around API, Application Programming Interface. Here is a hypothetical situation. What we have here is a brand new word processing software called WordAir, which is able to function on an operating system like Yosemite. At the same time, what we have is a brand new printer coming onto the market, which we're going to call Printer Extreme. What happens if I can? What happens is that WordAir makes requests via the operating system for services gained from the API. So any services which the API have, the WordAir word processing software will get them via the operating system. That means that Printer Extreme and WordAir are able to talk to each other. Now, what's the advantage of all of that? Well, it means that the printer does not need to know the source code for WordAir. It doesn't need to know how WordAir works. Similarly, WordAir does not need to know the intricate details of how the printer actually works, because the application programming interface is able to do all the hard work. If there was no API, then the developer of WordAir may have to completely revamp and reprogram this application software in order to be able for this software to work with this printer. In a nutshell, application programming interface makes it a lot easier for developers to be able for software to talk to hardware and vice versa, because the company of Printer Extreme in this case produces software, an API, for other software to be able to connect with. A real life example is this one here. What we have is Twitter. Twitter is a very popular social media site. The reason for that is because Twitter have produced a very effective application programming interface in which its software is able to interact with other companies' software. So companies such as BlackBerry, Android and iPhone are able to connect with Twitter software via its API. So people are able to use Twitter on both mobile devices and desktop, where we have programs such as TweetDeck and Seismic able to be used by Twitter. So the API which was created by Twitter is able to allow other companies such as these, as well as desktops, to interact with the Twitter software. So that will cover hardware independent. Another job is that of memory management. So the operating system is loaded onto RAM. The operating system needs to be able to allocate space in the RAM for particular software. A small amount of space might be needed, say, for Word documents and spreadsheets, whereas the operating system would need to make sure there's enough space available for software which needed much greater memory space, such as, say, Illustrator and Photoshop. Once an application is no longer used, so it's been exited, then the operating system needs to make sure that that application software is taken out of RAM, and so there is free space available. Then any other software which is called upon can be put into RAM. So the operating system needs to make sure that there is enough memory space available for any particular application program. Another job is that of the processing task. Operating systems need to be able to show multitasking. So, for example, if you have several users using a computer, then each of those users need to be allocated a certain amount of time or slice for them to be able to use a computer. So that will help with what is called scalability. So as the number of users come onto a particular network or a particular computer system, the computer is able to cope, or the operating system is able to cope, because it allocates a small amount of time for each user to be able to use the CPU. Now this is done very, very quickly and is done in a circular fashion. So because it's happening so quickly, every user has the impression that the computer is being used for them all the time. Whereas actually it is the operating system is allocating a short amount of time over a very, very short period of time for the user to be able to do his tasks. Another job of the processing task is to be able to have certain programs in the foreground but other programs in the background. The advantage of that is that a user might be using PowerPoint and then wants to go to the internet. Because these programs are in the background, they're able to come to the foreground very quickly, so no time is lost, and people are able to use various applications to be able to perform a task. So that is the processing task. The next one is that of the network capability. Well, networking is all about the idea of being able to send and receive data, as well as share resources. But it's also important to make sure that the network is secure. So there's the feature of having passwords and logins, and that data would be kept within the operating system. So when somebody does log in and password is given, the operating system will compare what has been inputted to its record on the operating system. If the two match, then that user can actually join the network. A final job of the operating system is that of file management. So the operating system needs to have a record of where files are stored. It needs to have a record of the size of the file. And it also needs a mechanism of avoiding conflicts in sharing files. So if more than one person is wanting to open up the file, what does the operating system do? Well, it might just say that one person is able to edit a document, but another person is only able to use the read-only facility. So those are the various tasks which an operating system does. The next form of software, apart from operating system software, is that of business application software. Here are three which we use a lot. Word will have features such as tables and spelling and grammar. But a more advanced feature is that of track changes and reviewing. This is a collaborative type of feature where many people can put input into what type of content is needed within a document, and then when everybody has agreed that, then after reviewing it, they can make a final edit. Excel will be involved with many functions, but is also very powerful for analysis, such as what ifs. So you can put in various variables, and with the use of goal seek and solver, find the best solution for any set input or variables given to a problem. Finally, we have this one here, which is Access. We use LibreOffice, but both are database applications. Databases will be used to manipulate. So manipulation is often done in tables where data can be merged, edited and sorted. But we also know that there are other major features to any database program, such as forms, which is allowing users to input data into the tables, queries, being able to interrogate or search for or filter particular information, and reports are used to be able to output the results in the form of a hard copy, such as a printout. A third type of software is that of utility software. Here we see disk fragmenter. The disk fragmenter, its job is to make the computer efficient. What we see up here are essentially files which have been spread all the way across a hard disk. The disk fragmenter will put all of these bits into one place. So it creates a contiguous file. That means that there are no gaps. So whereas before a program might have parts of its program scattered over a hard drive, the disk fragmenter will put them all in one spot. This means that the program can be read and written to quickly, and the whole process is much more efficient. A second utility is anti-malware. And malware is essentially hostile and intrusive programs such as keyloggers and spyware. A typical type of anti-malware is that of Windows Defender, which will obviously prevent that type of software getting onto your computer. A third utility software is compression. Here is a well-known one called WinZip. Its job is to zip up files or to compress them. By compressing files, we make them smaller and therefore gain some extra space on the hard drive. But it's also a way of being able to group a number of files and attach them to an email. A fourth utility feature is of encryption. Encryption prevents access from unauthorized people, and you can encrypt a folder, and then any files that go into that folder are automatically encrypted. The final utility software is antivirus software. In this case, you can set the antivirus software to automatic, so it will scan particular drives and files and root pathways, making sure that there is no virus on your system. Or you can do a virus check manually, such as with emails, CDs and DVDs. The way the antivirus works is through a footprint. In this case, what will happen is you will have updates via your your virus library. It will check those updates, and if it recognizes a virus on your system, it will either quarantine or delete. Finally, we come on to types of software. The first one is open source. Now this means that users can study, change, improve the source code. Generally, any of that type of manipulation of the source code is done by groups. Any changes to the source code, people are expected to be able to pass that open source code on freely and should not charge. The next one is freeware. Well, freeware is free, and this comes generally with lots of adverts. So freeware is sometimes known as adware. Generally, there's no technical support, but the freeware may come in with some built-in frequently asked questions or an extensive manual. There are also sometimes forums and support groups available, but not necessarily all of the time. Finally, shareware. Well, shareware is downloadable from the internet. It's generally free for a period of time, say 30 days. Then after that free time, you'll find that you'll either have to uninstall or buy the actual software, or the shareware you may find that certain features are disabled, or that a nag screen keeps on asking you to buy the actual software. So all of that information covers what is needed in the software topic. Thank you for listening, and bye-bye.